Hello, welcome back. Still your teacher, and today we are going to be talking about principles of GUI design. Let's quickly do that. Now, when we talk about GUI, I believe you already know what GUI is. That's graphical user interface. So, some of the principles that guide GUI design. For this class, you should be able to list and explain the principles of GUI. Apply this principle in the course of what? Designing. This is wrongly spelled. In the course, I think this is the right spelling. In the course of designing user interfaces for different categories of user. Okay, very important. So let's briefly go through it. GUI stands for, of course, graphical user interface. And in designing GUI for interaction, the main focus, of course, is usability. People should be able to use it and enjoy using it. The question is always, can the user use the system effectively and efficiently? These are the crux of a good or bad interface. If I'm able to use it, use what you've designed for me, but I'm not able to use it effectively and efficiently. Effectively, that means I can find what I want. Okay, then efficiently, that means that is efficient, the response time, the performance. Okay, I get what I want accurately. That is what is extremely important when it comes to interfaces. If your interface looks fantastic and is not working effectively and efficiently, that means I'm not able to do that. That's not my experience when I'm using it. Then you need to redesign your interfaces. Now, graphical user interface is the interface from which a user can operate programs, application devices in a computer. This is where the icons, menu, the widgets, labels exist for the user to access. Exactly, very easy. Just like this is an interface, as you can see. This is an interface with several buttons. So depending on what I want to use, I can click on this, click on slideshows, click on animation, click on transition design. Okay, and you can see that there are menus under it which I can select from. This is a typical example of an interface. Now, it is significant that everything in the GUI is arranged in a way that is recognizable and pleasing to the eye. Even though they said all that glitters is not gold, we are always moved by those things that are glitters, those things that look beautiful, that are orderly, well organized. So therefore, your interfaces must be well designed, colorful where necessary, with proper arrangement. The icons should be arranged appropriately. For instance, it's standard that when you have a website, okay, the home page button comes first. Now, if you don't even have the home page button, sometimes you use the icon or the logo as the home page, to your extreme left. It's not to the right, neither is it modeled up in between other buttons. Why? Because that is not the way it is. So there are ways that things has already been predefined. Not that they cannot be changed, but if you want to effect the change, then you still need to do a lot of training on you need to give a lot of training to your intending users, so that they don't get worked up looking for buttons and looking for things because they can't seem to find it, even though it is there. And of course, the button should be bold. The write of the text should be bold. I shouldn't be closing my trying to get stronger lenses in order to see what you're writing or what you've typed on each button. So it's very important. It must be pleasing to the eye, which shows the what that you are a good designer, you're artistic, you know what you're talking about. Now, what are the basic elements? Principles. Visibility has to do with clarity. Okay, Are the icons obvious? Can it be seen, or I'm fiddling with it? Feedback, information sent back to the user after an action. I think I've talked about it. It's necessary to give informative feedback when necessary. Avoidance, how clear is the use of what elements to the user? How clear are they? Okay. Then of course simplicity, keep it simple. This is one of the principles of good programming. I hope you've not forgotten. Keep it simple. Don't make things complex. Complexity does not show that you know how to do the stuff. It just shows that you know how, you are still trying to do simple things in a complex manner, which is not really good. Keep it simple. The structure are the elements set out in a meaningful way from the perspective of the user, not your own perspective, but from the perspective of the user. Are they okay with it? Are they fine with it? If they are not fine with it, then of course, for you to know whether they are okay with it is by they using it, and of course you can time it. How long does it take for them to complete a specific task? How long does it take them for them to create a page, or move from one page to the other, or get to where they can place an order and verify and confirm their order, or make the payment, and so on and so forth? How quickly are they able to receive of payment that they've made? That's what we are talking about. Then of course in the last bit we have consistency. Try as much as possible to be consistent with colors. Don't use blue on this page, then the next page you are using yellow or green. It doesn't make any sense. Pick your colors, okay, and then use them consistently. Why have you ever thought about why Microsoft has always used this blue effect on their either on their operating system or for their Office packages? Why? Because people are already used to the color. So yeah, I don't need to think twice. The moment I see a particular, what do they call it, a particular interface, I have an idea. Oh, this is Microsoft product, or is a Microsoft application. There has to be consistency, tolerance. Prevent user making errors, or provide easy recovery and graceful fail. Don't just because a user made an error, then the system crashes or just closes just like that. Just imagine you're entering your card details and you by mistakenly click on cancel. Instead of confirming, the game just went off, that logged you out completely. Then you now have to start all over again. It's not appropriate. So ensure you follow these principles when you are design for visibility, design for feedback, design for avoidance, simplicity, structure, consistency, and what? Tolerance. Thank you. Now the next and one of the most important aspects of human-computer interface is what we call the human-centered software evaluation and development. Now, everything we do, like we said, has to be user-centered. That means it should be user-based. You are putting the user is the king, just like we said our customer is the king. The user is the king. So whatever you do, yes, you have to do it from the perspective of the user. The objective of this lesson is to explain the activities performed in the my surprisation in human-centered software evaluation and development, and apply the identified activities in your coursework. Not sometimes I'm talking in the third person, in your coursework, in their, yeah, I think I'm correct, in their coursework, because I'm actually stating an objective. Okay. Now when we HCI design is considered as a problem-solving process. That is it. So it has to be taken as a project. So you have to plan for it. plan for the usage, plan for the targeted area, plan for resources. You have to, the resources as in the money, the time, the energy, the manpower, and of course the viability. Viability simply means that what is a simply most simplified word? I believe you should know what viability is. Viability, how possible it is for you to achieve it. How possible, for how realistic is the project. Of course, that is determined by the moment you start stating your requirements, and by the time you start, you now discover that, oh, there has to be some kind of trade-off. Trade-off simply means that, okay, maybe I want the performance of my system, I want the buttons to be this big, a particular size. Why? Because that is what the user wants. But then I also remember that okay, if I do that, then the particular bar where I'm going to place them, more buttons won't be, probably there will just be 2-3 buttons. So what will be the trade-off? If I really want to maintain that, then I will now need to reduce the sidebars, okay, of my website. Or it could also be that it has to do with trade-off in terms of resources that are required in running the application. So there are trade-offs. Trade-off simply means that, okay, you are trying to create a balancing act, and you are trying to let go something that is not very, very important in order for you to achieve something that is extremely important. Okay, that one may be, there are several things in computing. We do that a lot. I'll give you a very simple example. In networking, for instance, there are always trade-offs, because you have latency, you have redundancy, you have latency, you have performance, you have accessibility, you have security, okay, which all in a way boils down to quality of service. Now, if I need speed and performance, that means that my RAM size need to be up pretty high, okay? Now, if my RAM size need to be pretty up, that will increase the cost. Now, the question is, do I have the resources to do that? How much of it do I need? So there has to be trade-off. So I look at it in terms of scale of preference. Which of these is extremely important? Is it the cost? Can I bear the cost? If I should bear the cost, then if I'm able to bear the cost, then I'm willing to spend extra money for it in order to get maybe speed and time, and then even the resource sharing within the network. I can say that, okay, I have a web server, I have maybe a DNS, I have a DNS server, I have an email server. Now, each of these requires different percentage of resources. Which of these 3 servers is extremely important within the network? Is it the web server? Let's say that is the web server, because the web server hosts our customer web pages, which generates money. Okay, so I will want to allocate more resources to it. But then I discover also that the DNS is extremely important, because the DNS server is linked to the web server. So in that regards, I can decide to create a parallel, what they call parallel computing, whereby I create a balancing act. I can make it in a ratio of maybe 7 is pretty high, maybe 6 to 4, or in the ratio of 5, as the case may be. That is what we mean by trade-off. Sorry that I'm boring you. Anyway, the following points are the 4 basic activities of interaction design. You have identifying the requirement, which I have said over and over again. Building alternative design. Alternative design is that, okay, I want it this way, but if it doesn't work this way, are there other ways of me to do it, other ways I can do it? That's alternative. Then, of course, develop interactive versions of the design. Very important. There are a lot of tools that enables you to do that prior to your implementation. Okay, it may not be exactly the way you want it, but at least you can see that it's moving from one page to the other. If it's web page, you can use a simple HTML to just create buttons and say, okay, click this, it moves to this, click on this, it moves to this, to give you an idea. Evaluating the design, use feedback mechanism from your stakeholders, from the users, and so on and so forth. You can do that. Now, 3 principles for user-centered approach are early focus on users and tasks. Very important. Your users are your focal point. Okay, so what are the tasks or activities that you can do in order to ensure that you have your users on focus? A simple thing: engage them in every phase of the designing. You don't just wait until you implement it and just push it to them and force it down their throat. No, include them at the point of designing your analysis and so on and so forth, through feedback and constant meeting with her. Empirical measurement. Empirical, like I said, that forms the bedrock of every field. There are things you measure against it. A very good example is one of the standards in software is that you measure your success, the success of your software against a testing plan, and the testing plan is generated from your user specifications and requirements, as the case may be. So you can use any tool, a testing tool, to do your testing. You can even send it up like a prototype edition for people to use, and then you measure it against those things. Okay, if you find this, tick. If you find this, tick. If you didn't find it, also tick and explain. You can do that. Then of course you discover for every field you need to understand the empirical part before you can apply it. If it's AI enabled, okay, you know that you have to use certain algorithms, and algorithm, the empirical basis of it is mathematical. It is mathematical, so you need to understand the mathematical model behind it in order to utilize it. So important, very, very important to look at the measurement and of course evaluate it to see if it's going to be successful or not. Iterative, like a loop. You should be able to go around the design from the beginning to the bottom, from the bottom to the beginning, move over it. Don't try to build a castle from the roof. Start from the foundation, and for every foundation, ensure that it goes through it. What I mean is that at the point of the conception, you are going through the phases and you are iterating to see if there are any loopholes. When it gets to the analysis, you do the same thing until you finally get to your destination. Design methodology. Now, of course, there are various methodologies that have materialized since inception. Okay, of this, you have activity theory, but like I said, this is where we are interested in user-centered design. And what do we mean? This provides users the center stage in designing, where they get the opportunity to work with the designers and what technical practitioners. Users must be involved. Users must be involved in all the things that you do. It must be involved. Of course, even with the user interface design, there should be tolerance. We've talked about all that. Value sensitivity design. What exactly is the software solving? What problem is it solving? Okay, how valuable is it? Okay, is it conceptual, empirical, or technical? Conceptual simply means that is theoretical, is in the level of theory, you are still postulating. Empirical means that the research has been done and it has been proven over and over again in the use of different theorems to prove a particular point, and that forms the basis of what creating applications. Usually what happens is that most of the researches we do is applied. We are applying the empirical knowledge in solving things. The empirical is like electricity. The way you generate electricity is empirical. That doesn't necessarily change. You may have different ways of generating electricity, but the fundamental principle that is empirical does not change. So, but I can apply that knowledge in several other things in order to solve a problem. That becomes the technical aspect of it, because I'm actually applying it, but all the other stuffs are not really important. So you just go through it, put it for you to go through it. So in developing the human focused or centered software, there should be participation at all levels and in all the phases. I've said that over and over again. Is participatory design process involves all stakeholders in the design process, so that the end result meets the needs that are desiring. Don't assume that you know everything that the stakeholders or the users needs. Get them involved. So we have task analysis. You have the requirement analysis. You have the user profile, the user task analysis, the platform constraint in terms of resources, time, capability, of course the usability, design principle. Now all of this is extremely, at least this is important, the user task analysis, because now you are trying to identify how the user is going to use the system. So, and even the users, you can have different users. For example, the way a clerk will use the system, or a clerk, a receptionist will use the system, it will be quite different from the way an accountant or an IT director will use the system. So you have to create interfaces for each of them, and each user category must be involved in the designing of the system. Task analysis is the procedure to learn the users and abstract frameworks, the pattern using workflows, and the chronological implementation of interaction with the GUI. That means sequential, step after step, step after step, step after step. You build on it. Okay. Now user-centered, of the UCD, that stands for user-centered. You collect feedbacks from the user in order to develop your system. The drawback is that there may be passive user involvement. They may not want to. Okay, users' perception about the new interface may be inappropriate. Yes, it may not, because they may not have a full knowledge. And since they are not technologically inclined, not everybody will be technologically inclined, it may not be useful. However, their input is still very necessary. The designers may ask incorrect questions to users, which is very good. Remember, garbage in, garbage out is what you ask the users that they will give to you the answer. So if you don't ask the appropriate questions, then you will not get useful answers that will enable you to design useful interface. Then this gives you an idea how it works. You identify it, you analyze it. After analyzing it, you can evaluate it. After evaluating it, okay, you can, sorry, that is not correct. Let's follow the arrows. You analyze the data, then the proposed design. From the proposed design, you have an option either to implement straight away and deploy, or you develop a prototype, evaluate it, and go back to analyzing the data. So you can decide to come this way, this way, this way, or you go straight from this to this. Now, whether you are going from this to this or you are going from this to this aspect has to be defined. If not, it will be like a vicious circle. That means you can never break out. Okay, so be careful when you are doing iterative and you decide to go over and over again. There are times that you need to, if it's a prototype that was in, after you must have gotten the evaluation, the feedback, you just consider the feedback, then come up with an adjustable design and then go ahead to implement it since the input has already been made. Okay, thank you very much, and then we'll go for a little break and come back and continue with the class. Thank you.